This is lesson 15, and today we're going to talk about time series with pandas. So this is a topic that will be useful to a lot of you, and it's very relevant to data analysis. So if we just look at our schedule, we're on the GitHub page here. This is lesson 15. So we've only got 6 lessons to go. We'll do time series today. We've got some pandas group operations next time. We'll cover some statistics packages, the lesson after that, then interactive visualization with Bokeh after that, and then modules and classes, which are some more advanced ways of packaging your data or packaging your code to be reused, and then GitHub and Git on the last day. So we can click on lesson 15 here, and this will take us to the notebook for today. And so here's our lesson. We'll do the typical thing where we go to raw format, copy the link, and then go to the terminal, and we're going to change into SIO 209 lessons, and then do a curl -o, download that, source activate Python 3, and then Jupyter Notebook. And we're at lesson 15. So this is Pandas time series. So this this documentation is, or this notebook is adapted from the Pandas documentation. So if you, in fact, I can show you. So if you just go to pandas, pandas.pydata.org, or you can just Google Pandas time series, and you pretty much click on the first link. So this is the notebook we're using today is adapted from this documentation, and so you can, and this will have the latest version of the documentation that reflects the latest version of Pandas, which is 0.22, and I believe. Yeah, when I developed this was an older version, but most of the core functionality is the same. So with time series data, there's a lot of special kind of things you want to do with that. So, for example, you might want to generate sequences of a fixed frequency of dates or time spans, and you might want to convert between time series of different frequencies. You might want to compute relative dates based on non-standard time increments, for example, business days instead of regular days, or rolling forward or backward a certain number of days. And you'll see business days a lot in Pandas. That's because Pandas was developed by this guy Wes McKinney, who wrote the textbook that you're using, and he was working for a Wall Street firm, and he developed this package to be able to handle financial data. So it's got a lot of time series functionality, and a lot of it refers to business days in that sense, because that's a useful construct for financial data. For scientific data, it's less relevant, right? Nature doesn't really care if it's a business day or not, so that might not be as relevant to you. I'll cover it, but I won't go into as much detail about it because I don't think it's as relevant to this course, which is for scientists mainly. So there's a lot of really nice built-in stuff here. So we're going to use a few different modules today. So we've seen pandas and NumPy, and there's one called PyTZ and one called dateutil. So let's import those, and then we're also going to set the option display max rows to 20 and set a random number seed. Were you guys all able to import those? Okay. So I think those were probably dependencies of pandas when we installed it, so they should all be already on your computer. Okay. So first, a few examples. We're going to make a date range. So this is using this function pd.dateRange with a start date, a number of periods, and a frequency. And then we're going to index, or rather slice that that object, which is a date-time index. Oops, which is a date-time index. And you can see we're getting the first 5 elements of this index, which is basically an array. It's just a fancy kind of a NumPy array, basically. But it's a particular data type called a date-time index, which is a pandas object. And it begins with midnight on January 1st, 2011, and then every hour it increments. And so there's a 72. We can check this by typing len RNG, and this gives us the length of that object. We can do this. We can use that index now as that date-time index as the index for our pandas series. So we can make a random array of a random, normally distributed random NumPy array of length RNG, and then use RNG as our index. And then we can see that the index has this date time. It's a date time index, and then our data is just a floating point value, just like normal. So this is just like any other pandas series that we've seen, but it has a special kind of index. So one thing we can do is we can convert the frequency of this from every hour, for example, to every 45 minutes, and we can forward fill or pad the values. So, for example, let's say you had sparse data and you wanted to fill in gaps, or you wanted to change the frequency and just fill in using the value that was already recorded for that, for that hour, say, and you wanted to make it every 10 minutes, or in this case, every 45 minutes. You can use this as freq function. You can resample the data. So this is an example of a function that's kind of been deprecated. So that means in this newer version of Pandas, they're doing away with this way of doing it. But we can get the same thing using. We're basically resampling this data every day. So this is a 72-hour data set. So if we resample using D, which means day, that will just get a time point every day. And then, in fact, if we do yes, okay. Okay. Yeah. So there's, I think this might have saved over, but basically we're just, we'll cover this again in a minute. So this is just an overview. We are just taking a time point every day and then calculating the average over that time span.
Do we have to resample to get them? Is there a way to do it without resampling? Am I misunderstanding what we're
Yes. We'll cover this later. So yeah. I mean, we can. I think there's another way to do it, but effectively it's a convenience method for converting the frequency, and yeah.